Hi class, and so let's continue our exam number 3 review. And last time we stopped at the problem number 7. So today we will start at problem number 8, right? And we'll talk about the counting rules here. Okay, so let's take a look at the problem number 8 here. Okay, so number 8, let me change my color. Okay, so this is number 8. Okay, the number 8, they will tell you a game consists of asking 20 questions to determine the person, place, or things that the other person is thinking. This is quite a popular game, the American game, special for the young kids, for the long car ride. So that's why let's play the 20 questions games here. They even have a little kind of device, do that. That's kind of cool. Okay, so they say the first question is always you ask the person. So this is an animal, vegetable, or a mineral? Okay, and so you can tell the person, I think it's an animal, I think it's plant or vegetable, or I think it's minerals here. Now, all the other questions, you will answer yes or no. So for example, you are thinking about the dog, and then the other person asks you, this is an animal, you say yes. Then then the person will say, is this animal has 4 legs? Then you say yes. And then they said, okay, is this animal like living in the water? Then you say no. So that means afterward, each question, the answer is yes or no. So we want to figure out how many possible things can be distinguished in these games here when all the 20 questions are asked. So for this problem here, I know the first one, so because they asked you the question is animal, vegetable, and mineral. So you have 3 chances to do that. Then for after the 3 chances, each question is yes and no, right? So you will have 2 possible choices. So it's 2 possible choices for the second question. It's yes or no, yes or no. Then the third question, you have 2 choices here. So total is 2 choice, 2 choice. How many is the remaining questions? You have 19 questions remaining, right? So that's why when you answer all the 20 questions, the possible total combination for the things you were looking for could have 3 times 2 to the, because this is 19 questions, each question is yes or no. So how many power here is 3 times 2 to the 19. So, and when you put it into the calculator, so it will give you 157 and 2864. So you can think about so many things. So that's why in general, this is a pretty good games for the kids, because the choices here is a lot, and most likely you will get the answers here. Okay, so the next things here, okay, so that's the problem number 8. Let's take a look at problem number 9. The problem number 9, since we'll tell you here, okay, a lottery game requires you pick out 9 different numbers from the 1 to 86. So out of the 86 numbers, you pick 9. Then if all the 9 numbers match, then you will win a jackpot, okay? And how about if you only get the 8 out of the 9 numbers correctly, then you will win the 200,000. That's a lot, almost $250,000. So how many ways can you pick exactly 8 out of the 9 winning number? And we know when we play the lottery, the order doesn't matter as long as we match the 9 numbers here, right? Okay, so there are a couple different ways you can do it. So they will get the same answers here. So like in here, so the method number 1. Okay, so you can think this way here, right? So, the out of the 86, if the chance I get a jackpot is 886 to the 9, right? So let's say you get a jackpot. But And now we said out of these 9 numbers, so we have this many different way combination to get the jackpot here, right? After you pick out the 9 numbers, so what is the how many ways I can out of these 9 numbers I can pick up the 8? So this one's here, it will give you C, the 9 over 9 take 8. Okay, so that's that's the one way you can do it. And so this is we can put into the calculator, and let's take a look later. Kind of review the calculator. So then the method number 2, you can think of it in different ways here. So the method number 2 is here. You said, okay, so if I have 86, I'm picking up the 8 numbers, right? So after I pick up the 8 numbers, how many numbers I left here have left? I have 78 numbers left, right? And the one of them, right? So the one of them is what? So the 70, so 86, okay, so the 6, so you have 78 numbers left here, right? But one of them is what? One of them is the, the winning numbers of the jackpots, right? So you really have how many numbers you can pick here? You have 77 numbers you can pick in order to be exactly the same, like you have pick up the A numbers. Okay, so let's backtrack a little bit. Okay, so in here, when we talk about the 86 out of the 8, and then the remaining numbers here, we have 78, right? So we have 78. So that means here we can take the 78. And in order to get the one exact numbers here, that's what a while ago we talked about the 78. So 77 left, should be the 78 left. So you can put this into a calculator and get the values. I'm not going to do that because those values are extremely large here. That's why when you play the lottery, the chance to win is very small. But you can do either the method number 1 or method number 2 here, and so that you can get the same answer. So let's say here, no need to put the calculator, because you will get huge numbers, and so like e to the 11th powers, right? So that's okay. So we don't need to, but basically we understand the concept here. Okay, now the number 10s here. Okay, the number 10s, they said how many different letters, 4 letters station, radio station can be made, like a WFAA, KTMY, those things, right? Okay, so let's take a look at number 10, the part A. They said the first letter has to be a K or a W, and with no letter may be repeat. Okay, so let's take a look at this situation. That's how many possible situations we have here. So in here, now in here, this one's here, right? So we have the K or W. So the first one's here, you have no choice, right? So you have two possible situations, because this one tell you can either be a K or be a W, right? So after you choose this one, so for example, if you choose the first one, it's a K, then they say it's no repeat. That means that the next letter, you have 25 different choices here. Now you choose 2 letters, and now you have 24 choices here. Now you have 23 choices here, right? Now in here, because it's and, so you times that. So the total number of choices here, it will be 27600. Okay, so the part B is here. Let's see here. They say the repeat are allowed but the first letter still need to be a K or W. Okay, so I have 4 letters here. So the first ones here, they said, okay, I'm still need to be a K or W here. So that means I still have 2 choices here, right? So either be K or W. But since I can repeat, I can have a K, 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 W, 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 W. So it doesn't matter. So what is how many choice I have next one? I have 26. Because it's repeatable, so it's 26. And then this is 26, right? So I can times it. So now the total way I can find it is 35152. Okay, so now the part C, that's an interesting one. They say the first letter is K or W, no repeat. The last letter has to be R. Okay, so here we say, in here, they say no repeat. The first letter still has to be KW, and the last letter has to be R here. Okay, so let's take a look at this one here. How do we do that? So in here we say, okay, first letter is KW, so I have 2 choices here, right? So for example, if you choose K, but I know my R is reserved for the last ones here. So how many left? Because I cannot repeat. How many left? I have 24 left. After you choose the second letter, so how many left? You have 3 letters you have chosen. So you cannot repeat. So how many here? I have 23, right? And the last one has to be R. So it's only 1 choice here. So that's why you times it. So it's 2 times 24 times 23 times 1. So what do we have here? So we have 1104. So that's how many different way the stations we could have here. Okay, that's pretty cool, right? Okay, now let's take a look at number 11 here. So here's number 11. So the number 11 is like also is a kind of interesting problem. They said the Baskin Robbins, they have 31 flavors of the ice creams, right? Okay, so they said how many different double scoop cones can be made. Assume the order of the scoop does matter here, right? So take a look at the part A here, right? So that means here's my ice creams, right? So I have 1 scoop, I have a 2nd scoop here, right? So they said, the order does matter. So whatever I have the first scoop and whatever I have the 2nd scoop, it matters, right? So like in here, then you say, okay, the first scoop, right, I can have is 31 choices here. I can have any choices here. And then for the 2nd scoop, they did not say have to be a different flavors. So the 2nd scoop still can have a 31. So it's 31 by 31. So how many? We have 961 different scoops here. All right. So now the part B is here. They said I have the 2 scoops, right? And they said with 2 different flavors. So that means here, if this is your ice creams here, so the 2 different scoops here, right? So whatever you have in here, the first scoop has to be different to whatever you have in the 2nd scoop here. So you can say, okay, that is the situation. That means I'm going to have a 31, whatever I choose the 31. But after I choose the first flavor on the first scoop, what happened to my top? My top only have a 30 left, right? So I have a 31 times 30, and so it's 930. Or because the order matters here, right? So instead of doing this counting rule, use the permutation. So you say it's a 31, you take a 2 color. So it will give you the same 930 here. Okay, so now let's see here, the part C is here. So they say for the scoops here, I have a 1, 2, 3. So I have 3 scoops here. And then for these 3 scoops here, favor, has to be different. I have 3 different flavors here, right? So I said I have 3 different flavors here. But then the problem said the order of the scoop doesn't matter. So like for this scoop is I have the red on the bottom, blue and orange. If you switch the, the color, doesn't matter. So if the color doesn't matter, so we know it's a combination. That means the scoop, the order doesn't matter, right? So I have a 31. I have chosen 3 here. Okay, so you can use your TI-84 calculator, and then you can get these numbers here is 4495. So if you have 3 scoops of the ice cream, you have about 4,500 different combinations you can have. Okay, so now let's take a look at number 12 here. Okay, number 12 is interesting. It said, suppose, okay, so the number 12 here said, suppose 5 cars are randomly drawn from the well shuffled 52. What is the probability all the 5 cars are red? Okay, this is, okay, so here we're going to apply the counting rule. So if you withdraw 5 cars, and because I'm playing the bridge, those things, the order doesn't matter, right? I give you the 5 cars. So the total number of the the way is C, the 52, take a 5, right? So that's the total sample space is 52 takes 5, right? So this is a total number. So this is the total number of the sample space. Okay, so we put the total number of the sample space on the denominator. So let's say, what is the probability all the 5 cars are red? So all the 5 cars are red. So we know we have 2 red suits, right? So we have what? We have a heart and we have a diamond. Both these 2 suits are what are red, right? So now I said all the 5, so total how many I have? I have a 26 red car. I need to take a 5. Right, so it's a 26, the red car, you take a 5 here. Okay, so you can put into a calculator to get the numbers, what is the probability. So that will be, I will leave for you to do that. So it's pretty easy, just put into a calculator and then calculate that. Okay, now part B is here. Okay, so the part B is what is the probability at least 1 car, right? So I'm looking for the at least 1 car is red. Right, so like we talked this before, we said at least, that means 1 car, right? At least 1. That means you could have what? You could have 1 car is red. You have 2 red cars, right? So you have 2 red cars. You have 3. So you could have 2 red cars. You have 3 red cars. You have 4 red cars, or you have 5 red cars too, right? So that means 1 red car or 2 red car or 3 red car or 5 red cars here, right? Right, so that's why it's over, right? So we have 1, 2, 3, 4. Okay, so let's take a look at 1 red car. So will be what? C, the 26. We have a 26 red car. 2 red cars, 26 of the 2, 3 red cars, 26 of 3, and the 4 red cars, 26 of 4, and the 5 red cars, 26 over 5. And also we talked before, if you see the keyword is add, so the or is what? Or is a keyword. That means I use addition rules, right? So I need to add all these things together. And overall, the sample space, right? So sample space here is C, the 52, take a 5, right? So this is one way you can do it. And so if you do this way, then look at, you need to put into the calculator how many times? 5 times, right? So you need to calculate the C26 1, 26 2, 26 3. You need to do 5 times. How about if I say at least, if I, instead of drawing 5 cars, if I draw 10 cars, then when I say at least 1, then you need to add like 10 times. That's a lot of calculator punches here. So when you see the at least 1, right? So one thing here, this is kind of important, the probabilities here is simplified. So in here, you might want to remember that when we say at least 1, to simplify that, you can say at least 1, you can do that is the 1 minus the probability known, not any. So in here, we can interpret at least 1 car, right? So let's see how simplifies here. We said at least 1 car, at least 1 red car. I can say, hey, I was 1 minus probability, no red car, right? So this is a pretty important kind of a simple shortcut, right? If you say that at least 1, then you can do is 1 minus none. So, okay, so now the problem be easy. So you say 1 minus no red car, right? So my sample space is still is 52 over 5. So no red car, that means that you need to pick out from what? You need to pick out from the black cards, right? So for the black cards, I also have 2 suits. I have a spade and a club. So total how many black cards I have? I have 26 black cards, right? So that's basically no red cards. That means I need to pick out the 52. No, I'm sorry, not the 52, right? So I have 26, right? So I have 26 black cards. I need to pick all these 5 black cards, 5 cards from the black. So don't get confused here. We both have 26. This 26 refer to the black card 26 here. Then you can use your calculator and try to find the answer for this. Okay, so now last part here. So let's say, what is the probability 2 diamonds, 1 club, and 2 hearts? Okay, so I'm going to find the probability 2 diamonds, 1 card, right? So and 1 club and 2 hearts. Okay, so as soon as you see this, you recognize there's a keyword I'm looking for is and, right? So if it's the and, then you know you need to do the what? The and here is what? We do multiplication. Remember, that's what we said, or is addition and end is multiplications here, right? Okay, so now let's take a look what is our answer. So our sample space is still is C what? Our sample space, okay, is, let's see here. Okay, so it's a C. Yeah, so the sample space we have is C 52. Take 5 cards here, right? 2 diamonds. So I know the 2 diamonds is out of the 13 diamonds, I need to take 2. one club is out of 13 club, I need to take one. And two hearts, out of the 13, I need to take two. And because it's and, so what I need to do, I do the multiplications here. All right, so now you can put this into your calculator and then get the answers here. So this, you know, we're going to, this is a good place to stop at this video, because this video basically will talk about the counting rules and how to use the counting rules for the probabilities, right? So so here is the summary. So we learn is the counting rules, right? So the counting rules about the, so it's the permutation. So remember the permutations, order, now matter, right? And the combination, order, what? Matters, right? So that's basically we have. And then the way we find the probability, you use the counting rules, you find the probability here, just like we did it before. So you find the total number of the sample space and the total number of your events, right? So this is the number of the sample space and number of the events. Now, how do you find the total number of the sample space, total number of the events? You use the counting rules here, all right? Okay, so now this is our exam review part 3. So the last one, we're going to finish the, we're going to finish, we have one more tape, and we'll be able to finish these reviews here, okay? So don't wait until you can start looking for the review problems, and you can do it, okay? So I will talk to you next time. Bye.